This will be the first of a few videos on the gradient vector. So what you see here is a surface and then a gradient vector on the surface. So we got our surface is 1/4 x squared plus 1/2 y squared. And then we have our gradients right here, our first derivative, with respect to x, and then the first derivative with respect to y. So if you recall, the gradient, you have your surface here. The gradient is the two-dimensional vector. It's a three-dimensional surface. The gradient is a two-dimensional vector composed of f sub x and then f sub y right here. So what I've done is, in order to create that on the surface, is I call f sub x the derivative with respect to x. In order to type this out on Desmos, this is you do f and then underline x, the underline key, and then it'll make it a subscript, and then f, and then a subscript of y would be f underline key, and then it'll put a y there. So f sub x. That's what you can call this, m and n if you want, but I just want to be more precise. All right, so h is a point on the curve itself. So if I take off the vector, you see the point is on the curve itself, and I just called that h. And then j is going to be, I call j my gradient vector, f sub x, f sub y, and then 0, because you got to put a 0 in there, otherwise it'll create a different kind of vector entirely. And then my vector is going to be h, the point on the surface itself, and then h plus j, h comma h plus j is the vector. And what that does is it makes the gradient vector start on the surface itself when you do h plus j like that. All right, so anyway, that's how I created the gradient vector, and you can see that as you get lower on the surface, the gradient vector gets smaller, and as you go higher on the surface, the gradient vector gets bigger. Okay, so I think that's probably better seen like this. Yeah, it's much smaller. That's because the gradient vector it gives us information about the steepness of the graph. All right, and so this is a great way to show that the steepness of the graph is getting less as you go down the graph. And for a elliptic paraboloid like this that would be the case. You can now, if you do all these formulas, you can go up here and you can change this to like maybe a saddle, and then you can look at the vector as it goes up and down and around the saddle itself. You can even look at this in the version of the XY plane, and you can kind of see, I don't know if you can really see it, you can see that the vector is getting steeper as it goes up and down that object. All right, so notice this is on the object there, and so it's getting less and less steep as you get towards the origin. And so maybe you can see it if you take out the surface itself, see how it's getting longer. Anyway, play around with that. It's a cool little function.